All right, so for the end of the week, we're going to look at two sections in chapter 10, 10.1 and 2, and it's on solving systems. So we're going to start off with just kind of what the definition is, and then we'll do an example word problem where we set up a system, and then we'll solve it after. Okay. So a system of equations. It's more than just a single equation with a single variable. It can have two or more equations with two or more variables. So we're generally going to stick to the rule where you're going to have the same number of equations as you do variables. If you don't, then interesting things can happen. So let's say I gave you something with more variables than equations. Okay, I'm going to give you something with two variables in one equation. That's two variables, one equation. There's an infinite number of answers to that. If x is 1, y is 3. If x is 0, y is 2. If x is 5, y is 7. So there's an infinite amount of answers. What can happen in the opposite case is if I give you more equations than variables, then you can end up with a no solution. So if I gave you something like x plus y equals 2 and x plus y equals 5, well, I'm basically asking you to find, actually no, that's impossible as well. That's an example of a no solution, because you're trying to find two numbers that add up to 2 and two numbers, the same numbers, add up to 5. No, that doesn't work. But if you had something like, let's just make it a little simpler. 3x equals 2, 8x equals 5. Now you have two equations, one variable. That's impossible. You can't multiply a number times 3 and get 2, and then multiply the same number times 8 and get 5. Doesn't work. So that's a no solution, because you have more equations than you do variables. Doesn't mean that always happens when you have more equations than variables, but we're going to stick to, if you have 3 variables, you're going to have 3 equations. Okay? And that makes it always work out to one solution for what we're going to do. Yeah, 3 variables, 3 equations, it'll always be one solution. Yep.
So if, say, 8x equals 5 had a y in it somewhere, would you still get no solution if the top one didn't have y?
If it had a y in it?
Yeah, the first one didn't.
So now, let's see. So now you might be able to solve that. Yeah, I think now you might be able to solve that, because if you think of it from a graphing perspective, okay, this is basically the line x equals 2/3. That's the top one. And this is the line x equals 5/8. Those are two vertical lines. They are parallel. They would never cross. Okay, those are two verticals. Once you add a y into the bottom one, what you're kind of doing is making it y equals mx plus b. That's y equals negative 8x plus 5. That would be a line with a negative slope. The top one is still a vertical line somewhere, so they will definitely cross now. So yes, if you add a y, that now has a solution. All right, so we'll start with 2 equations and 2 variables, and then we're going to go to 3 and 3. Even in linear algebra, I think the most that I normally ever had to do was 4 and 4. That was pretty common, 4 variables, 4 equations. We didn't go much above that, because if you can do 4 and 4, 5 and 5, it's just now, this is taking longer and longer to do the same stuff. All right, so for this one, I just want to set up the system. So I want to find the length and width of a rectangle that meet a certain criteria. In this case, the criteria is that the perimeter is 100 and the area is 300. So first thing we're going to need is the 2 formulas for perimeter and for area. Now for this shape, I would expect you to know the formulas. Okay? I wouldn't put the formulas on the test. If it was something strange, like an octagon has an area and a perimeter, I wouldn't expect you to know the formula for the area of an octagon. Okay. Might be able to figure it out, breaking it up into triangles or something, but if it's a common shape, you should know the formula. Okay, let's start with area. Jay, what's the formula for area of a rectangle?
Length times width.
Length times width. And Dylan, what's the formula for the perimeter of a rectangle?
2 times length plus 2 times width.
Yep. And now we'll fill in what we know. P is 100, A is 300, and that's our system. So we get 300 equals length times width. And now if that's all you had, that's an infinite number of answers. You have more variables than equations. So 2 numbers that multiply to give me 300. 1 and 300, 2 and 150, 10 and 30. Okay, there's an infinite amount of answers. What's going to narrow down the answers is now this next restriction. The perimeter has to be 100. Okay, so there's our system, which we'll come back and solve in a little bit. Questions on setting up that system? So the 2 methods that we're going to look at for solving systems are substitution and elimination. For a 2x2 system, you can really use either method. Sometimes the problem is set up and kind of geared towards one of the methods to be a little faster. When you start to get into a system with 3 variables and 4 variables, then substitution usually isn't the way to go. Substitution gets pretty awful when you have 4 variables and up. We want to use a special form of elimination when we start to get to that many variables. Not quite the elimination I'm going to show you today. It's elimination with a matrix, which we'll look at tomorrow. All right, so the idea for substitution, we should already know this, but can someone kind of summarize for me how you solve a system if you're using substitution?
You get one variable equal to something, and then
Okay.
plug it into the other equation.
Yeah, so you're going to isolate a variable in one equation, and then you're going to take what you do in step 1 and plug it into the second equation. Once you get through step 2, you should know one of your answers. So for a 2-variable, 2-equation system, you have 4 choices you could make at step 1. You could solve the first equation for x. You could solve the first equation for y. You could solve the second equation for x. You could solve the second equation for y. So you have 4 different choices. Usually the problem is going to be set up so one of those 4 choices is easier than the others. Take that result, plug it into the equation, the other equation, and simplify. Now you're going to know one of your variables. And now you take that answer and you plug it back in to find the other variable. Even when we start dealing with matrices tomorrow, we're still going to do this substitution idea at the very end of the problem. Okay, you'll find one variable. You're going to take and plug it back in to find another one. And then you might take those 2 and plug them back in to find the third one. And actually, even when we do elimination, like the kind of elimination I'm going to show you today, same kind of elimination you did back in Algebra 1, that method still involves substitution as well, because you find one variable, and then you plug it back in to get the other variable. So substitution is really part of all the methods. Okay. All right, so let's do this one, but let's use the same variables that we did. Excuse me. So we have 2L plus 2W. and then L times W equals 300. All right, so which equation here would be easier to get a variable by itself in? The top equation or the bottom? Yep. Yeah, I would say the bottom, because anytime you have variables with coefficients of 1, usually you just have to do one step to get it by itself. If you've got a coefficient of 2, well, then you've got to move whatever else is not that variable, and then you've got to deal with the 2. So let's deal with the bottom one. And, well, Gracie, what letter do you want to solve for in the bottom one? W. All right. So Sam, if we get W by itself, using the bottom equation, what would that equal? 300 over L. Okay, so now we've got a formula for W. And once I get L, like let's say L was 10, then I just do 300 divided by 10, then I have W. So I'm going to come back to this formula at the end eventually. So now we're going to plug it in for W. All right, so we're going to get 2L plus, and now we want double that fraction. So when you double the fraction, remember, you don't double the top and double the bottom. That wouldn't do anything. If you want to double this fraction, you just double the top. So it's 600 over L. Okay, equals 100. All right, what kind of makes this a little bit of a pain to solve is we've got this fraction in here. What could I do? I'd have to do it everywhere, but if I do it, I could get rid of having a fraction here. Megan?
Multiply by L.
Yeah, we could multiply everything by L. Now, when you multiply an equation by the same number, there's one number you're not allowed to multiply an equation by. What number is that? It's the only number you can't multiply both sides of an equation by. Yep.
0.
0, because if you multiply everything by 0, then you wipe the whole thing out. You just have 0 equals 0. But I'm multiplying by a variable. So how do I know whether or not the length is 0? How would I know that before I even finish solving it? I don't have to know what the length is. I just have to somehow guarantee that it's not 0 before I go any further.
Because it has to have a length that has a perimeter.
Yeah, if you don't have a length, then you don't have a rectangle. You don't have a four-sided shape. So guarantee you L is not 0. Okay, so let's do it out. We get 2L squared plus 600, so the L's cancel, equals 100. Okay, and now from here, Jan, what kind of equation do I have?
Quadratic.
I have a quadratic, so solve it. I don't think it's going to factor, so we're going to have to use quadratic formula. But to use quadratic formula, there's a couple things we could do first.
Wouldn't it be 100L?
Yes, 100L, thank you. If it wasn't an L, then it would not be as hard to solve, but there is an L, yes. All right, so anytime we want to solve a quadratic, we have to get it equal to what? Yep. 0. So we always want to keep the squared term positive. We usually write it in descending order, which is what I'm doing right now. And before we jump in and use quadratic formula, there is one thing we could do to kind of simplify that a little bit. Anyone see Leo?
You can factor out the 2.
Yeah, we could factor out a 2, divide everything by 2. In this case, it wouldn't make a difference. Just makes the numbers a little smaller, but we're going to use a calculator anyway. So L squared minus 50L plus 300. So we're solving for L. Okay, the reason we're solving for L is because of the decision we made way back at the beginning to get W by itself. Okay, so let's plug it into the quadratic formula and see what we get. Abby, can you tell me how to write it out just plugging into the quadratic formula?
Isn't it b? So would it be negative 15?
Opposite of B, so negative B.
Yeah, so it'll be positive. So 50 plus or minus the square root of 50 times 1.
You remember that part of the square root of, what comes next, Megan?
It's 50 plus minus the square root of b squared
B squared, which I'll do that part out. So 2,500.
minus 4ac.
So minus 4. What's A in this case? 1. And C? 300. Okay. Over 2A, which in this case A is 1, so it's just over 2 times 1, which is 2. All right, so I can definitely see we're not getting a nice square root out of that. We have 2,500 minus 1,200. So that's going to be the square root of, what's 2,500 minus 1,200? Trevor?
What was the question?
What's the square root come out to there? Square root of, you don't have to give me a decimal on it. I just want to know what the radicand would be.
1,300.
1,300. Yep. No. Yes, you are right. Sorry. Yes, square root of 1,300. And that's the answer. So now we just have to plug those in and see what they come out to. And actually, we're going to get 2 answers, right? Unless one of them comes out negative, but I already know the square root of 1,300 is smaller than 50, right? Because if you take 50 times 50, that's 2,500. So even if I do 50 minus the square root of 1,300, it's not a negative number. So both answers are going to work. Right, so we'll call them length 1, length 2. So the first one, we've got 50 plus square root of 1,300. Let's just do that first. Divide by 2. So I get a length of 43.03. Now we're a little off with rounding, so you'll see what's going to happen in a second, but I think you'll get the idea. Okay, now the other length is 50 minus the square root of 1,300 divided by 2. 6.97. Okay, so we have each of our lengths. Now that I have the lengths, what else do I have to find? Yeah? The widths. So to find the widths, just take 300 divided by the length, and that's the width. So let's try that here. Let's take 300 divided by L1, 43.03, 6.97. So that's width 1. What do you think width 2 is going to be? Yeah.
43.03.
Yeah, I think it comes out to like 43.02 because of rounding, but yeah, it's 43.03. So what does that really mean? Like, why are there 2 different answers to this problem? What's the difference? Yeah, Sam?
Would it be just which side do you pick for the length?
Yeah. So one way you're looking at this rectangle and saying that one fits the conditions. The other way, you are looking at this rectangle. Whoa, that looks like a parallelogram. Somehow I guess my rectangle's not that good. So let's use that. Okay, so there's one rectangle. The other rectangle is just this one rotated 90 degrees. And that's the other answer. So technically, are there 2 different rectangles? I guess there are 2, but they're congruent to each other. Doesn't that look a lot longer when I rotated it than that one? It's like an optical illusion. It's the same rectangle, but it looks longer. It's the same length, but when I rotate it. Maybe it's me. Maybe it looks better. I don't know. It looked longer. I don't know. We'll check the video footage. Instant replay. All right. So here's another system that is set up for substitution or the next method, elimination. We'll do substitution one more time, and then we'll get into elimination. But out of the 4 choices, solve the top for x, top for y, bottom for x, bottom for y. I think one of them is the easiest. Anyone tell me which equation would be the easiest to pick, and then which letter in that equation we could solve for quickly? Yep.
The top and you solve for y.
Yeah, I would take the top and solve for y. And if you do that, Abby, what do you get?
You could do negative 2x plus y.
Yep, if you're putting it in like y equals mx plus b form, like if we were getting ready to graph, that would be a good idea. Even for substitution, you can do it that way as well. 5 minus 2x, negative 2x plus 5. Same thing. Now we take that, plug it in, and see what we get. So because of that decision, we decided to find x first. Then we'll come back and find y. All right, so we get 3x. Anytime you do substitution, it's always a good idea to put parentheses because it's double y. So whatever you change y to, in this case a binomial, 2 terms, you have to double each term, not just the first one and the second one. So 3x plus 2y equals 2. And how about Juliet? If I distribute that out, what would I get?
Minus 4x plus 10.
Plus 10. And now we just got to combine like terms and get x by itself. So we get 3x minus 4x is negative x. 2 minus 10 gives me negative 8. So x is 8, but we're only half done with our answers. We're like 90% done the work, but we still have one more answer to find. So just take that, plug it back in. X was 8, so negative 2 times 8 gives me, yep, so negative 16 plus 5. So y comes out to, yeah, negative 11. Okay, pretty straightforward, nice system to solve, no fractions, no decimals. That doesn't always happen, but that's the idea of substitution. Okay, question on that? It's basic stuff. So let's move on to elimination. So elimination is when you add one equation to another equation. Sometimes you have to multiply the equation by a constant first, but the goal is either to make those numbers opposite or to make those numbers opposite. Either way, okay. Probably the same amount of difficulty in this problem. And the reason you want them to be opposites is because if one of them is a negative 3 and one of them is a plus 3, they cancel. And then you're dealing with only one variable, and then you can solve for it. Technically, you could get them to be the same or opposite, but I want you guys to just think of it as being opposite, and then you add them. If they were the same, you would subtract them, because subtracting 2 things that are the same gives you 0. Adding 2 things that are opposite gives you 0. But it's easier to think of it just that way. And even though we're not doing a matrix today, this is kind of getting towards the idea of a matrix. I don't know if any of you saw when you came in what I was doing on the board. There was another student in here, and I had a bunch of numbers up. We were doing a matrix. Which involves getting a lot of zeros, getting things to cancel out. So it might be necessary to multiply one or both equations by a constant. You have to multiply both equations by a constant when one number is not a multiple of the other. So like, if you had a 7x plus and then a bunch of stuff, and then you had like a 21x plus, and then you had a bunch of other stuff, you'd only have to multiply equation 1 by -3. If you do that and then add, the x's would cancel. But if I do something like this, yes, you could multiply by a fraction. Like, you could multiply by 5/7 in the top equation, or -5/7, but that's going to be a mess. That's going to cause everything to become fractions. Fractions with sevenths are kind of messy to work with. So the idea here would be, let's multiply the top by 5 and the bottom by -7. And there's other ways to do it, but the goal would be get a 35 in one spot, get a -35 in the other spot. And then when you add -35 and 35, they cancel. Okay, so if we look at this one, 2 is not a multiple of 3. Or 3 is not a multiple of 2. 5 is not a multiple of 3. So you're going to have to multiply both equations. If you want to get the x's to cancel, the goal is going to be to get one of them to be a 6, one a -6. If you want the y's to cancel, we're going to make one number a 15 and the other number a -15. All right, so I'll let Rebecca, I'll let you pick. Do you want to try to cancel out the x's or the y's? The y's. All right, so if we want the y's to cancel, we're going to try to make one a 15 and one a -15. Now, if you wanted, you could make one of them a 30 and the other one a -30. That would work too. But smaller is easier, so we'll go smaller. Okay, so what would we have to multiply the top equation by to start to get us in that direction? 2 options. Yep.
5.
Yeah, you could multiply by 5, or you could multiply by -5. Either way, that's going to make it a 15 or a -15. But I'll go with the first thing that Abby said. So we're going to multiply everything by 5. So now we've got 10x. You got to do it everywhere, not just where you want to do it, the whole thing. Plus 15y equals 25. And now that she made that decision for the top, there is only one number to multiply the bottom by. What would Julie have?
-3.
We've got to go with -3. So now that's going to give me 9x. Let's see, minus 15y equals -63. Okay, let's add those equations up and see what we get. Tanya, when I add everything up, I already have it in columns, x's, y's, numbers. You got to make sure that's okay. I should have mentioned that. Line up your like terms in columns. Now we can add. So what do you get when you add in columns here?
19x, 0,
Yep, 0y, so I'm not even going to write that.
and where is that? 38, -38.
-38. Yep, looks good. Okay, any questions on that? And now we're at the last step. So to get x by itself, Shauna, what would I finish up with?
Divide by 19.
Divide by 19. And Dylan, that tells me that x is -2. And now this is where we do the substitution. Pick either equation, plug it back in. I would probably pick the top one, because the numbers are a little smaller, and then solve for y. So we've got, let's just do this as we go. 2 times -2 is -4. Plus 3y equals 5. And Gracie, can you just walk me through finishing that up to solve for y?
You add 4 to both sides.
Add 4 to both sides
And then divide by.
and divide by 3. So we get y equals 3. Now, if you were to graph this 2x plus 3y equals 5. What shape would that look like? It's not written the way we would normally write the equation for this shape, but what shape would it look like? Okay,
Could just be a line.
it's a line. Yeah. And how about the bottom one?
Would that be a line too?
That's another line. So if you were to draw these, the top one is a line, the bottom one is a line, and the answer is a coordinate. What's the significance of the coordinate -2, 3 in relation to those two lines? Yeah? See?
That's where the 2 lines intersect.
It's where the two lines would cross. So another way to solve this system, which we don't do a lot of now, we did it more in Algebra 1, is graph it by hand and see where they cross. This would be a good one to do because they cross at nice numbers. Okay? Graphing is kind of a pain when you get answers like we did with the rectangle problem. You'd never be able to figure out that accuracy graphing with paper. But on the calculator, you could. All right, so any questions on that one? All right. So, if you think of that analogy that I just made about drawing lines, that'll help you figure out what the 3 different cases that can happen are. Okay? We've already seen the first one. 2 lines, just like in the last problem, you draw them, and they cross in exactly one spot. What else can happen if you draw 2 lines, besides having them cross in exactly one spot to give you one solution?
They don't cross at all.
They don't cross at all. If they don't cross at all, you would be drawing what kind of lines? Parallel. So that's another thing that can happen. And what's the third thing that can happen if you draw 2 lines? Megan?
Infinite solutions.
Infinite solution, and that would mean they're the same line. So just to use different colors. 2 lines right on top of each other. Every point is a solution. So we're going to solve another system with elimination, and we'll look at what happens algebraically when you have those 2 cases. Okay, let's try this one. So again, this is set up for elimination. Could you use substitution? Absolutely. But I really think elimination is easier. And this time I think we can get away with just multiplying one equation. All right, so JM, which equation, actually let's start with this. Which variable do you want to get rid of?
X.
Okay, let's get rid of x. So what would you have to multiply the top equation by
3.
to make that happen? Yep. And that's it. Let's do that and see what happens. Okay, so that equation turns into 6x minus 9y equals 15. In the bottom equation, we're going to keep it the same. Negative 6x plus 9y equals 10. Okay, let's add those up. Leo, what do I get if I add those up?
You get 0.
Okay, yep, so I get 0x
Yeah, you get 0x and 0y
plus 0y, so that whole side is just 0.
equals 25.
25. Okay, at this point, you're done. You just have to interpret what that means. 0 equals 25. So, yeah,
No solution.
there's no solution. That's a false statement. The answer is not false. The answer is there isn't an answer. No solution. So this is the case where if you were to graph these lines, they have the same slope. Same slope, different y-intercept. They're parallel. Okay, so that's a no solution. Let's look at this one. Anyone see what's going to happen here? Yeah?
It's going to be 0 equals 0.
Yeah, these equations are repeats of each other. If you just double everything in the top equation, you get, or even if you wanted to say multiply everything by -2 in the top equation, it's exactly the same as the bottom equation. So you've written the same equation twice. So effectively, what you've done here is you don't really have two equations. This is one equation, two variables. And I showed you that earlier. That's an infinite amount of solutions. Okay? But if you didn't notice that right away, multiply everything by 2. Oops. Put your other equation first. So negative 2x plus 6y equals 4. Sometimes it works. All right, add them up. The x's cancel, the y's cancel, and negative 4 plus 4 is 0. You get a true statement, which is infinite solutions. If you were to graph these two lines, they are both the same line. Same slope, same intercept. Okay, graphing works okay for 2D, or for two variables, because all you're really doing is drawing two-dimensionally, x and y axis. When you start getting into x, y, and z, okay, into a third variable, graphing isn't that easy because now, instead of drawing lines, you would be drawing planes. Okay, so think of like a piece of paper that goes on forever in each direction. And you'd be trying to find where planes intersect each other. Kind of hard to draw. So we're going to stick with elimination. The first kind of elimination we're going to do, this one's not my favorite because it's a little less organized and you have a lot of choices. The second type we're going to look at tomorrow is with a matrix. But all I'm going to say about a matrix today is that it's an efficient way to organize your data so you don't have to write down as much. I'm not going to show you how to do it with a matrix today. All right. So I'm going to try to simplify the steps as much as I can, but it's really something you just have to do it. So we're going to pick one variable to be eliminated in two of the equations. All right. I'm going to try to reword it a little bit. So pick one variable to be eliminated in two of the equations. Step 1. Step 2. Pick two different equations. You can't use the same two you just used. You got to pick two different equations. And eliminate the same variable again. And eliminate same variable again. So after you do step 1, you're going to end up with an equation with two variables. After you do step 2, you're going to end up with a different equation with the same two variables. Now you're going to have two equations with two variables, and we can proceed from there just like we did before. So step 3. Now you should have two equations with two variables. Solve that system just like we learned how to solve before. Substitution or elimination. So solve as usual. Nothing new once you get to that step. Okay, but the key is you try to make life as easy as you can because fractions can pop up a lot here. So we'll try to avoid them if we can. It doesn't mean every problem is going to be nice numbers, though. So here's our system. So 3 equations, 3 variables. It says 2x plus 3y minus z equals -1. 3x minus 2y plus 2z equals 15. And x plus 4y minus 3z equals -8. So the reason I don't like this method as much, at least doing it this way, is because you have a lot of choices. You can pick any 2 equations you want and eliminate any variable you want. But then you have to do it again a second time with different equations. So, does anybody have a thought which two equations we might want to pick and which variable we would want to try to eliminate? Generally, if you have a 1 in front of a number, that makes life really easy. Makes eliminating other things not as bad. Okay?
You could do the first two and solve for C.
Okay. And that's also fine too, because technically you've got a 1 right there. So it's going to be pretty easy to get rid of Z in a couple equations. Right? So let's do the first two, and we're going to get rid of Z. So I'll just write what we're doing. Eliminate Z in the first two equations. Equation 1 and equation 2. All right, so Jane, since you suggested that, I'll let you tell me how to do it. How would I get rid of Z in the first two equations? What would I have to multiply something by?
You would multiply the first equation by 2.
Yep, the way I'm going to write that is like this. I'm going to say 2 times the first equation. So anything with a circle around it represents an equation. And I'm going to write that down. So we've got 4x plus 6y minus 2z equals -1. It's super easy to make a mistake here. So if I copy a number or a sign wrong, just let me know, like I just did. So make sure you multiply everything by -2. I'm going to double check it. 4x, 6y, -2z, -2. All right, and then right below it, I'm just going to copy down equation 2. Not going to do anything to it. 3x minus 2y plus 2z equals 15. Okay, and I like what he did there because now we're automatically going to get rid of the z's. Okay, so Leo, what's my equation going to be when I add all those up?
7x plus 4y equals 13.
Yep. And what I'm going to do to give that a name is I'm going to call that equation 4. So now we've got one equation with 2 variables. We got to get another one. It has to have an x and a y in it. So now, if I scroll back up, what 2 equations could I pick this time? And you can't do 1 and 2 again. But we have to eliminate z in which 2 equations this time? Yeah?
1 and 3.
Sure. You can eliminate z in 1 and 3. And now I need the directions for how to do that. So Sam, how would I eliminate z in equations 1 and 3? What would I have to do?
You can multiply the first equation by 3.
I like the idea of multiplying the first equation, but we got to be a little careful with the number we use.
Would it be a
-3. Because
It's a -1, right?
Because it's a negative, right, because if we multiply by -3, we're going to get +3, -3,
Okay.
cancels. So we're going to do -3 times the first equation. All right, so -6x minus 9y plus 3z equals 3. And now we're using equation 3. Can someone just tell me what equation 3 is so I don't have to keep scrolling back up?
X plus 4.
Yep.
Y.
X plus 4y.
3z equals -8.
Maybe. Thank you. All right. So,
-3, and then end of the first one equals.
oh, it's a -3? Yes, thank you. Did we do everything else right? -6, -9, plus 3.
Oh, never mind, I'm wrong. Yeah, it's supposed to be plus.
Oh, yeah, no, it was supposed
No,
to be
I forgot
positive.
it was a -3.
Okay. Everything else looks good now? Okay. So add them up. negative 5x. Negative 9y plus 4y gives me negative negative 5y equals, and then 3 minus 8, negative 5. Now, if we wanted, we can call that equation 5, or actually we can make equation 5 a little, we can write a simpler version of it. What could I do there? Gracie? Yeah, if I want to make everything a little smaller, just divide everything by, you could do negative 5 or positive 5, either way. I think you said negative 5. So that would be x plus y equals 1. We'll call that equation 5. Any question on that? It's not necessary, but it's going to make the next step even easier. Now we're going to deal with equations 4 and 5, and we're going to eliminate a letter in those two. Okay, so let's, you could do substitution or elimination. Well, I'll let someone pick. Sam, do you want to do substitution or elimination?
Substitution.
Okay, which equation do you want to solve and get a letter by itself in?
5.
Okay, I like equation 5, definitely a lot better than 4. And what letter do you want to get by itself there? X. Okay, so what does x equal?
1 minus y.
Yep, x is 1 minus y. All right, so I'm going to go back up, and I'm going to plug that in to equation 4 for x. So this, we're kind of doing like a hybrid here. We're doing a little bit of substitution and a little bit of elimination. Again, there's lots of different ways to go about it. All right, so now I'll just write down what we're doing. Solve for y using 4 and 5. Specifically using substitution. All right, so we've got 7 times x. X is now 1 minus y. Plus 4y equals 13. So that gives me 7 minus 7y plus 4y equals 13. Let's just combine the like terms. Negative 7 plus 4y is negative 3y. I'm going to bring the 7 to the other side. By subtracting it, and I get 6. So y is negative 2. Okay, so now we've got our first letter. We've got y. Now, plug in y into that box, and that'll tell me what other letter. Rebecca? 3. And what letter did you just get? Yeah, we got x. So x equals 1 minus y. Once you get one letter, the rest of them come pretty quick from here. So now we have x is 3. Last letter I need is z. To find z, you can't use equation 4 or 5 because we eliminated z out of those. You've got to go back to an equation that has z. And it doesn't matter. So, Trevor, do you want to use equation 1, 2, or 3 to find z? 3? All right. So we've got 1x. So that's going to be 1x is just 1 times 3. So you got 1x plus 4y. Well, y is negative 2. So 4 times negative 2 is negative 8. Minus 3z equals negative 8. Well, there's a lot of ways we can do it. If you add 8 to both sides, you can just cancel those right away. And In Algebra 1, I probably wouldn't mention that because that might confuse people because normally you combine like terms first. But it's up to you. So if you add 8 to each side, those cancel. And then move the 3z to the other side. And we get z equals, Gracie? 1. So when you go up from a 2-variable 2 equation to a 3-variable 3 equation, the amount of work goes way up. It doesn't just go up like a little bit, it goes up a lot. Okay, and people have spent a lot of time trying to figure out what's the best way we can do this and not have as much work. And that's more of a problem for computers because 3 by 3 people can do by hand, but what if you had 100 by 100 variables? 100 variables, 100 equations. You want to get the fastest way to do it possible. And a lot of people do research into that to try to find what's the fastest way we can do it. And that involves matrices. The method that I'm going to show you with a matrix is very good for humans, okay, because it's very predictable. It has a pattern to follow. Computers can do it even better than the way that I'm going to show you, but it wouldn't make sense to you. You'd have to do really weird things that would make 0 sense, but a computer can just do them so fast that it's more efficient for a computer to do it a little differently than humans would try to do it. So a matrix is basically just an efficient way to write things down. If you do anything with programming or computers, does anyone do anything with programming computers? A matrix is called an array a lot of times. And an array is basically, in this case, just a bunch of numbers. That would be a matrix that represents the left-hand side. You don't write any letters the way we're going to solve it tomorrow. Just a 1, a 2, a 3, and a 1. And on the other side, we do a separate matrix for that, 4 and a 10. Those brackets represent a matrix. Matrices can store all kinds of stuff. Maybe if we had a database, okay, for the school, maybe names are in the matrix, first names. And there's another matrix called last names. And what you can do is you can link them together. So you can have the name of a student, just pulling the first name from one area, take the last name from another area, and make sure the ID numbers match. That's how you put the right things together. That's basically what I do with the sign-out system. So every time you sign out, there's a matrix on the computer that has every student ID number, name, grade, social security, no, not social security, but your name, your grade, ID number. So when you scan your ID, the ID number goes in, and then when you scan like bathroom, what it does really fast is it takes that ID number, it looks through all 200 students that I have in there, finds, oh, okay, 1, 2, 3, 4, 5 ID number, and then it says, what's the first name for student ID 1, 2, 3, 4, 5? What's the last name? Puts them together, and then says checked out 2, and then whatever barcode you scan. It looks up, oh, barcode 105 is bathroom, 104 was dean's office, something like that. So that kind of uses a matrix. But we're just going to stick with putting numbers in a matrix. That's all we're going to use it for. All right, so the homework tonight is 1 through 21, just the odds. A lot of those are 2-variable and 2 equation. I think the last couple problems are 3 variables, 3 equations. Don't forget, I will be after school tomorrow for extra help. And anybody that needs to make anything up from last week, it's got to be done by Friday.